So for this problem, what it asks us to do is, it wants us to construct a triangle, a special triangles to help us find the functions. So one thing, back in your geometry class, one thing we want to remember, the reason that we got our coordinate points was by using our special triangles. And if you guys look at a special triangle over 45, 45, where those two angles are 45 degrees, and that's your 90. Is it an isosceles triangle? Correct. And the one thing that we determine is, let's say if these 2 points are 1 and 1, then what we end up doing by using Pythagoras theorem is that's going to be the square root of 2. Let's say both those sides are 1 and 1, right? Well, then you have 1 squared plus 1 squared equals c squared. So you have 2 equals c squared, square root, c equals the square root of 2. Okay?
How do you know they're 1?
Well, how do I know they're 1?
Yeah.
They can be 2 or 4.
I was just giving them any kind of, property. I was just saying that's a lot of times when we teach using the teach using the right triangles, that was just the relationship between the two. If the way that I taught it with the unit circle is I said, well, we know that the radius is 1, right? Right? The radius is 1. So then you could say these two are the same. So you could say a squared plus a squared equals 1. So you have 2a squared equals 1. So then what we said is a ended up equaling, after you do the square root of 2 over 2, you end up equaling the square root of 2 divided by 2. And that's what I showed you guys on the unit circle, right? Well, this is the same thing. If I divide, what happens? That's not
Is that right?
the same. Well, what happens if if I divide, what happens if I divide all of this by square root of 2? Then you would exactly get this exact same answer down here. So it's just a relationship. When you're talking about the special triangles, it's just using a relationship of the two. Or a relationship between the sides and your hypotenuse. So here, you guys, we're asked, what is the cotangent? Well, we know that the tangent is opposite over adjacent. So therefore, your cotangent is going to be adjacent over opposite. So what we need to do is we just need to pick our side. Instead of 45 degrees, these are both 45 degrees, so it doesn't matter which one I pick. I'll just pick this one to be our angle. So my opposite side is 1 over 1. Then it says cosine of 45 degrees, which is 1, your adjacent, over your hypotenuse. And I have to rationalize the denominator. Okay? And cosecant of 40, or let's write that down. Cosine was adjacent over hypotenuse. Cosecant, remember, is your sine, is 1 over sine. So cosecant is 1 over sine. Well, what was sine? Sine is opposite over hypotenuse, right? So it's opposite over hypotenuse. So to find that, the reciprocal is hypotenuse over opposite, because as those cancel out. So your hypotenuse over your opposite. All right, so what they want you guys to do is they want you to construct your right triangle, or I'm sorry, your special triangles. They want you to construct your special triangles when given what angle. So if it's a 30, 60, 90, you construct a 30, 60, 90 triangle. If it's a 45, 45, 90 triangle, just construct the 45, 45, 90 triangle. One thing I want you to understand is if you would have constructed this way, if you do your math again, do it the same answers, you're still going to get the same answers as what I did. Because it's just the relationship of a 45, 45, 90 triangle. It doesn't matter really what I put in there as long as I find the other two. Does that make sense? As long as you understand that these two side lengths are equal to each other.
You can have 4 on 4.
You know what?
Yeah, absolutely. It's still going to reduce down to, you're still going to have to find out what your hypotenuse is, and then it's still going to reduce down to what your trig values are. Yes?
The relationship is like the hypotenuse is equal to the side and square root of two.